Yes, today we are going to learn rationalization. So for a few minutes, I'll be waiting for everyone. So let's have the class. So prior to learning with the basics of Surds, those who want to learn Surds, they need to learn rationalization first. Unless you will be clear with rationalization topic, you cannot learn Surds topic. So what is Surds? So here, let's move out with the general questions here. So a root type of questions are there. How you are going to solve it? This is simple simplification of root. So whenever we are having any number in root form, so here this we call third root of 4. And the same way, if we are multiplying this with 16, this is also third root. How to multiply these type of questions? So for this kind of questions, whenever the root number is same, if the root number is same, we can multiply the number internally. So here 4 and 16 is there. Multiply them. So 16 fours are 64. And we are having cube root of that. Now, what do you mean by this? So here, for this kind of questions, we need to find its prime factorization. So here it is 64. To find the prime factors of 64. Either you can go with 2 or with the 4. Choice is yours. LCM you can find by your own. So here, let's work with 2. That is 3 is 6. This is the 4. Again starting by 2. 2 was the 2. This is the 12. Further again, 2 is the 16. 2 4 is the 8. 2 is the 4. 2 ones are 2. So here we got the prime factor. 64 we can replace as 1, 2, 3, 4, 5, 6. 6 times 2 is there. So this we are going to replace with 2 raised to 6. 64 we got 6 times 2. And this is cube root. So we will write this in fraction. Whatever number will be there in the cube form, that under root, that number to be taken in fraction. Now both will get cancelled here. Here 3 ones are 3, 3 twos are 6. The numbers got cancelled. So finally we are having here now 2 square. 2 square is nothing but 2 is being multiplied 2 times. So here final answer is 4. So let's start out with one more example. These are the basics. Unless you know how to solve this kind of questions, it's very difficult for you to learn with first part. Now the next question, like here in question number 2, okay, Ananya, nice. So this I started with the basics. Okay, to learn chapter like third, first you need to go through with the normal sums like how to find out its factors and how to find out the rest of the like first tier. This we call root form. And whatever number will be there in root, we need to find out as per that. Here, suppose 3 is there, this we call cube root. If there is 4, we call it as fourth root. If there is 5, this is called fifth root. Whatever number will be there inside, we need to get that many pairs. If nothing is there, it is square root. If suppose only like this, without any number, we'll be making pair of 2 numbers. If there is 3, it is representing third root. If there are 4, 4 numbers representation is there. If there is 5, they are representing 5 numbers. If suppose the first question as I did, 64 is there and it is cube root. What do you mean by that? Can everyone hear clearly? Is my voice audible to you? Here 64 cube root is there. We are going to find out the prime factors of 64. Here the prime factors of 64, they are already I did, where we got 2 6 times. So how we are going to write it? 2 raised to 6. Whatever number you are getting, that you need to write with that representation. We got 2 raised to 6. And now it is cube root. Whatever number will be there in the root, that we will write in fraction. So it is 1 by 3. Now cancel them. So 3 is getting, 6 is getting cancelled by 3. We got it as 2 square. 2 square is nothing but 4. Okay, Srivalli, Yashmit, all of you like that. Can you hear properly? One of you respond me. Is my voice clear to you? Is everything clear? Srivalli, will you respond? No one are responding. Okay. Now this is a type of question. So let's move out with the, okay, maybe Yashmit, you are having some network problem. Yeah, I'm having Wi-Fi. Okay, now the next question. In your book, I found questions like, okay, this kind of questions I'll explain two more. 243 upon 3. Both are in cube root. So how we are going to find out? Both are in cube root. We need to check like whether the numbers are having the same power or not. Here, 3 is also in cube root. 243 is also in cube root. So here, when both are in cube root, we can cancel the numbers internally. So here we'll be cancelling the number, cancel out them. 3 8s are 24, 3 1s are 3, like the fractions. For this kind of questions, it is very compulsory that numbers must be with the same power notation. Here, they are in cube root. Then only we can cancel. If the numbers are different, we cannot cancel them. And take it out with the basic. Once you learn the basic, you'll be able to solve the sum. So we are cancelling them. Now, when you cancel, it's 81. Now we are having 81 in cube root. What else I told? Once if the number is in cube root, we need to find prime factors of that. So here 81 is there. Find the prime factor. 81 comes in 3 tables. 2 to the 6, 3 sevens are 21, 3 nines are 27, 3 threes are 9, and 3 ones are 3. Okay. In the question, it was 4. By mistake, I wrote it 3. Now, whatever answer you are getting, here we got 3 4 times. So we'll write it like 3 raised to 4. As 81, we are getting 3 4 times. So 81 we can replace as 3 raised to 4. Now here, fourth root is there. So whatever there will be in the root, that we will write in fraction. So that I wrote like 1 by 4. So this 4 and this 4 will get cancelled. So answer is 3. This we completed, like how we are getting 3. Now the next question, here simple multiplication type of questions can be there. Like if suppose 3 plus root 3, you need to multiply by 2 plus root 2. These are nothing but, okay, you responded to very nice, very good. Smith. Now here, we need to multiply the number. So how we are going to multiply? Simple like in algebra, how we multiply. Here also, though the numbers are in root, no need to worry. Simple multiplication only. First write down 3 and whole bracket. 2 plus root 2. Next, again root 3 is there. First write the first number, then the next number, whole bracket to be repeated. Simple multiplication. 3 2s are 6. Now 3 and root 2, they are unlike numbers. We cannot multiply numbers. We will place it like 3 root 2. And the same way, here also root 3 and 2. So 2 root 3. Now the last one we are multiplying both the numbers which are in root. Root 3, root 3. Root 3 is 3. Out of all these, this is 3 root 2, this is 2 root 3. Again, both are different numbers. We cannot add them. Here, the root parts must be same. Then only they can be added. These are called fractions. Here, 6 and 3 is there. 6 plus 3 is 9. So here, 9 plus 3 root 2 plus 2 root 3. This is final answer. So here, let's move on with the next question. One more question. Here it is 3 plus root 3 and 3 minus root 3. This question in this form. Mostly in your chapter, you are going to get questions of this type. Here 3 plus root 3 is there, 3 minus root 3. This is a plus b and a minus b identity. A plus b, a minus b, we can write as a square minus b square. Out of them, this is a and this is b. We will make 3 square minus root 3 square. This is a and this is b part. 3 square minus root 3 square. Now 3 square is 3 3 is 9. For root 3 multiplied by root 3, number will be 3. Because it is 3. Simply we can subtract it. 9 minus 3 is 6. This is the final answer. Now in your textbook, you are having questions on what like the rationalization which you are going to have. If you remember, question was, suppose it's 35, 2 root 35, and here 12 is there. This kind of questions I'll be taking now. How we are going to solve this kind of question. So here, first of all, if it is completely under root, if you recall, first question, it was root x. So we'll put root overall. We need to find multiples of this number. First step. Here, this is 35. Multiple of 35 is 7 5s are 35. Whatever number you are getting, you will place that in root. So here it will be root 7 square plus root 5 square. 7 5s are 35. Whenever you find the answer, clearly you can notice that by adding both the numbers, you will be getting the first number. So we will replace numbers with root form. Root 7 square. Why we have taken root 7 square? Root 7 is nothing but root 7 multiplied by 7. That is 7. 7 can be written as root form with square. So here 7 we will write as root 7 and 5 as root 5 and then 2, this is A, this is B. So 7 multiplied by root 5. Overall there is root. Now this is similar to the identity A square plus 2AB plus B square, which we can write A plus B whole square. So here we are going to replace this with A plus B whole square. Root 7 plus root 5 whole square. So answer is root 7 plus root 5. This is that as answer. Is it clear? Around 6 members joined and then again everyone are leaving. I don't know who is at present there. Are you there? Someone joined with the name Bunny. I don't know who is that. Okay. Moksha is there. Moksha, you took textbook. Not having textbook. Many times I called also, but there was no response. Bunny, are you there? Shivali? Okay, all these are not there. Just for name should be joined, I think. Okay, now this is what we got the answer. So let's move on with one more question. Suppose you want to find out your 12 is there. The question is in this form. What is the first step for this kind of questions? We need to find the factor of this number. So here 12 is there. 3 4s are 12. The next step I told like we'll be writing both the numbers to prove. Here 7 can be replaced by always try to put big number first. Here out of them big number is 4. So root 4 square plus 3 square 2, then both the numbers in multiplication. The first step is root 4 square. Just split it out. Then whatever the big number is there, make square of that. Then again the next number square. Then with 2, both the numbers to be taken. Again overall root, a square, b square, 2ab. Now we'll keep them in whole square form. A plus b whole square. Once they are in square form, the square and root will get removed. Finally, we are having 4 plus 3. Square root of 4 is 2. Root 3, we cannot take the root. So this is your final answer. Hope this is clear. I think it's clear for everyone. Now solving one more question and I'll wait for your comment where you will be providing answer to me. So in the next question, here, the root 56. See, when you are solving IIT level of questions, by splitting directly answer you can know. Here 56 is there. Factors of 56, 7 8 are 56 and 7 plus 5 is 8 plus 7 is 15. So direct answer you can think. By seeing question itself, you can say the answer. 56. It's 8 sevens are 56. The final answer will be, if you are plus, it will be root 8 plus root 7. This is final answer. If your minus is there, we'll put minus. Got it clearly? Have you got this answer? Some of you please respond. Is it clear? Okay. Now, if suppose how I did this question, once again I'll be repeating, like 56 is 8 and 7. So here we are going to write 8 square plus 7 square. Who is this Bunny? I don't know the name. A square, B square, 2, A, B. Overall it is A plus B whole square. Okay, not getting. Okay, we'll solve with two more examples. So here we got the square. So the square will change as root 8 plus root 7. I'll repeat with one more example. Suppose question is in the form like here, 2 9 plus 2 root 20. What we have to do? First we are finding factors. Okay, let's see here. 20 is there. 20 factor we need to find. 20 comes in 4 tables. 4 5s are 20. Or it comes in 10 tables. 10 2s are. You need to check by adding which two numbers we are getting 9. What will be the answer? By adding which two numbers we are getting 10? We are getting 9 by 4 and 5 or by 10 and 12? With 4 and 5. Here, out of them, whatever the bigger number, okay, that we have to take. Bigger number is 5. So here, 5. First write down the big number, make square, then smaller number, make square, then write down both the numbers. Here now, someone responded. It's not clear. Is it clear now? Understood how I got? We'll make square of that. A plus B. As here plus is there, the plus will come square. Final answer is root 5 plus root 4 is 2. This is final answer. If same question is there, like instead of 9, if here it is 12. How are we going to solve? Instead of 9, here it is 12. We already got the factors. Factor of 20 is 2 and 10. Even 4 and 5. Second step, what I told, we need to check by adding which two numbers we are getting this number. By adding 4 and 5, we are getting 9. By adding them, we are getting 12. So our choice will be 2 and 10. Now the next step, whatever numbers you got, out of them, big number to be taken first. Square. Then smaller number. Again, make it square. Then 2 and both the numbers. Is it clear? Again, making root of that. Now it's a square, 2ab. So it is a plus b whole square. Once you are getting whole square will get removed. Here you need to remember only 2 points. The first one, which number is there inside. So this is the first one. Which number is there? But the second step is find its factors. Then add and check. By adding which two numbers we are getting the first number. Okay, that to be selected. Out of them, the next one, big number to be taken first, smaller number to be taken next. Then from there, you can conclude with the answer. Is it clear to everyone, those who attended? Clear? The final answer is root 10 plus root 2. Is it clear? Can you hear? No response. Okay, now one more question. Now here 45 is there. And here 15 is there. So 15, let's take 8 over here. 18 as 15 is a 45. The question is under root 18 minus 2 root 45. Will you answer? Will you try to answer? What will be the final answer? Is there anyone who can answer? First, we need to split out 45. If you will be splitting 45, it's the 15 3s are 45. 15 plus 3 is 18. So, how we are going to write our answer? Big number square, small number square, the minus is there, so minus, then both the numbers in multiplication. Clear? Now after that, the next step is making square. If your minus is there, we need to make minus in between. So finally, square and root will remove. Thus the final answer is root 15 minus root 3. This is final answer. So most probably all of you understood how we are getting this kind of questions. Now I'm going to teach you rationalization. What do you mean by rationalization? So here, if suppose the number is there in this form, 1 upon root 7. And if they will say rationalize, what do you mean by rationalization? Rationalization means whatever the number is there in root, you need to multiply that with the denominator and numerator both. So your root 7 is there. You're going to multiply root 7 to both. Now the question is like, why we are multiplying to both? In math, we cannot make math or what? In any subject, we cannot make changes as per our wish. If we are multiplying means we have to divide also. So both are getting cancelled. Means no changes remain. So we multiply the numerator and denominator. Now finally it will be root 7. Root 7 multiplied by root 7 is 7. This is final answer. Very good. Mukha is correct. Now the next question, like if it is 5 root 3. Now you can think like what should we multiply? Always we will multiply only the root part, not the extra things. So if your 5 root 3 is there, so we are going to multiply root 3. Thus it is root 3 upon, whenever we multiply the root will get removed. Root 3 multiplied by root 3 is 3. 3 5s are 15. The answer is root 3 upon 15. Is clear? The third, one more question. If suppose it is 2 plus root 3, then here you are getting the sums what you are having in your book like. If a single number is there, we are going to multiply with the root part. If suppose two numbers are there, what we are going to do? Two numbers are there, we will take opposite sign of this and will multiply both the numerator and denominator. So it is 2 plus root 3, we will make it 2 minus root 3. That we need to multiply both the numerator and denominator. So multiplying 2 minus root 3 to both. If your plus is there, we will multiply with minus. If your minus, we will multiply with plus sign. Now how you are going to multiply? You are multiplying a number with 1. So there will not be any change. Write down same as it is. Now for the second part, it is in the form of a plus b and a minus b. As it is in the form of a plus b and a minus b, so you are going to write a square minus b square identity. So here, this is a, this is b part. A square minus b square. So finally, 2 minus root 3 upon 2 square is 4, 3 square is 3. The final answer is 2 minus root 3 upon 4 minus 3 is 1. No need to write. So this is your final answer. This we call rationalization. Let's move with one more question here. 1 upon 5 minus root 5. What we are going to do here? So whatever the term is there in denominator, we are going to take that with opposite sign. So it is 5 minus root 5. So we multiply this by 5 plus root 5. So that is 5 plus root 5. And the next step, don't make any changes in the numerator. As we have 1, if suppose here instead of 1, 4 is there, what we are going to do? We need to multiply the number simply as we multiply. So here it is 4 5s are 20, then plus 4 root 5. The first number we multiplied with first one, then first with the second one. 4 5s are 20, 4 root 5. Here the terms are in plus and minus. Thus it is a square minus b square. Now, numerator to be kept as it is. For denominator, will make 5 square is 25 minus, when if any root form is there, only its root will get removed. So here we will have 5. So finally, these are unlike terms. We cannot add them. Thus it will be 20 plus 4 root 5. And here 25 minus 5 is 20. This is final answer. Got it? Is it clear? Okay, what you want? If you are tired, I'll wind up. If you are fresh enough, we can go with a few more minutes. Shall I continue? No response is there. Shall I continue? Will someone respond? Why did 4 come there? Okay, okay. Why did 4 come there? Okay, this, for example, I explained like instead of 1, in the question, if 4 is there, what you are going to do? Okay, if 4 is there, simply like multiplication, we multiply. This I multiplied 4 5 are 20, 4 root 5. Okay, and this we did like a plus b, a minus b. The same kind of question, I'll ask one more example will solve. If suppose here 7 is there, and then uh, in numerator one more thing is there, like 2 plus root 3. This is there in numerator. And in denominator, there is 4 plus root 5. How we are going to solve this? Okay. Now here, whatever is there, first I kept 1 only. With 1, you will not, like, question will be very simple. We are learning step by step. With 1, no need to multiply anything. The sum will be same only. To make it little complicated, I replace that 1 with 4. These are not from the textbook, like simple examples I'm explaining so that you will get it clearly. Okay. Now here, if suppose it is 7 in bracket, 2 plus root 3 is there. Here in denominator, 4 plus root 5 is there. First step, here 4 plus root 5 is there. We are going to multiply opposite of this. It is 4 minus root 5. Same thing we will write here also, 4 minus root 5. Most probably first step is clear to all. Now what we are going to do? Leave the 7. Don't get confused with that. Okay? Or let the 7 is not there. Only with 2 terms first we will learn. Then I'll make it much more complicated by adding one more number. So here 2 plus root 3 is there. 4 minus root 5 is there. How are you going to multiply it? First number to be taken first. Then whole bracket. Second one. Again second number. And whole bracket. In denominator, first number square. And second number square. As they are in plus and minus, so we'll make square of that. Now the next step is like you need to multiply. 2 4s are 8, simple multiplication. Then 2 root 5 minus 2 root 5 plus 4 multiplying by root 3, which is 4 root 3. Both the numbers are having root. Inside the root, we can multiply. So it is root 15. In denominator, 4 square is 16. Root 5 square is 5. Now go with the final solution. Here, all the terms are unlike. 8 is there, no single digit number is there. Here, root 5 is there, root 3 is there, root 15 is there. All are different numbers. We cannot add them. So, final answer will be only by subtraction, we'll leave them as it is. So, 8 minus 2 root 5 plus 4 root 3 minus root 15 upon 11. So this is the final answer. This we call rationalization. So this is very simple. Only the number we are multiplying. Okay, nothing else. Like simple multiplication only we are solving the sums. Okay. So let's move with one more example. If suppose question is root 3 minus 1 upon root 3 plus 1. So we are going to solve for this. 3 minus 1 root 3 plus 1. As I told, first step we need to multiply opposite of denominator. Here root 3 plus 1 will multiply root 3 minus 1. Okay, now after one more question, I'm going to wind up. So as it is already 9:45, it's your time to sleep. Okay, otherwise it will be difficult for you to get up. Will I continue for 15 more minutes till 10? Will it be okay? What do you want? Okay, here 3 plus 1 is there. So 3 minus 1. We are going to multiply opposite with both. Now here see both the terms are same. When both the terms are same, we are going to use whole square identity. Two identities we are going to use here. One is a plus b whole square, a square plus 2ab plus b square, or it can be a minus b whole square, where it will be a square minus 2ab plus b square, or a plus b, a minus b, which is a square minus b square. Only these two identities we are going to use. To be clear with that, now in this, both the terms are same. So it is nothing but a minus b whole square. And here it is a plus b, a minus b. So this identity we are going to use. A square minus b square. Let's move further. Here a minus b whole square. Does it is a square minus 2ab. This is a, this is b. A square minus 2ab plus b square whole divided by root 3 square is 3 minus 1. And finally, root 3 square is 3. Whenever we are making square, we remove the root. Minus 2 multiplied by root 3 is 2 root 3. 1 square is 1. 3 minus 1 is 2. So here it will be 2. Now add the numbers. 3 plus 1 is 4 minus 2 root 3 divided by 2. Okay, move to 2 plus 2 root 3 is the correct answer. Okay, let me see. Plus will not come up. So here minus is there. Here it is a minus b whole square. Na? So in front of 2 minus will come. Now finally you can see that both the numbers can be divided by 2. So we can take 2 as a common. If I take 2 as common, 2 to the 4 and this 2 I have taken common. So only root 3 will be there. Whole divided by 2. Now both 2 will get cancelled. The final answer is 2 minus root 3. Is it clear? At the same time, one more question I'm going to explain. If suppose it is root 3, 3 plus root 7 upon 3 minus root 7. So what is the first step here? We need to take opposite of this. It's 3 plus root 7. 3 plus root 7. Always see only denominator, no need of this numerator. 3 minus root 7 is there. We took opposite of minus, that plus is taken, and we multiplied both numerator and denominator with that. So both are same. It is a plus b whole square identity. That is a square 2ab plus b square. Root 7 square. In denominator, a plus b and minus b. So it is a square minus b square. Now the final answer, 3 square is 9, 2 3s are 6, root 7, root 7 square is 7. Now 3 square is 9, root 7 only 7. Whenever we make the square of any root number, answer will be without root. 9 plus 7 is 16 plus 6 root 7. 9 minus 7 is 2. Now check out if the number can be divided by 2. We can divide 16 by 2. We take 2 common. 2 8 are 16. Divide next number also by 2. 2 3 are 6. 2 7. Whole divided by 2. Now 2 is getting cancelled. The final answer is 8 plus 3 root 7. Is it clear? Is it clear? Most probably everyone understood. I'm not getting any response. Now one more question. So here I'm making little typical now. Try to get that. So this is like after learning this part, your 50% things will get over. Then tomorrow we can move out with the chapter. Like what questions whatever there in the textbook. Here question is 5 plus 2 root 3 upon 7 plus 4 root 3. So what is the first step which is told? Here once again explain last one. Okay, you want me to explain that last question once again. Here it was 3 plus root 7, 3 minus root 7. What I did first, opposite of this to be taken and multiply to both numerator and denominator. So here 3 minus root 7 is there, 3 plus root 7 I multiply. Then here you can see that both the terms are same. When the terms are same, they are a plus b whole square identity. So that I wrote the identity a square plus 2, this is a, this is b. So this is 2ab plus b square. And denominator it is a minus b, a plus b. We'll make it a square minus b square. Now 3 square is 9, 2 3s are 6, root 7, root 7 square is 7. Now adding both the numbers, 9 plus 7, 16. This we cannot add as it is unlike term. So keep this aside. Here 3 square is 9, root 7 square is 7. Subtract them. 9 minus 7 is 2. Now both the numbers are divisible by 2. So we can take 2 common. If 2 is taken, 2 8s are 16, 2 3s are 6, root 7. Whole divided by 2. So 2 will get cancelled. Thus the final answer is 8 plus 3 root 7. Is it clear now, Moksha? Okay, let's move with the next question, which is whole line. Okay, in the next question, it's a little complicated. You can see here. Here I've taken two numbers. 5 plus 2 root 3, 7 plus 4 root 3. First step is always think. You have to take the opposite of denominator. Here it is 7 plus 4 root 3. So we are going to take step. We are going to have multiplication. First we're taking the first number, whole bracket of the second. Now the second number, again, whole bracket. Repeating once again, first number, whole bracket, second number, whole bracket. With sign you need to take. Here it is in plus and minus. We are making first number square minus second number square. Now multiply them. Simple like multiplication as we do. 5 sevens are 35 minus 5 fours are 20. How we got this minus? Here it is plus. Plus minus minus. Multiplying these two numbers, this plus, the plus, 2 sevens are 14 root 3. Now multiplying these two numbers. See here how to multiply. First, 2 fours are 8. Root 3 multiply by root 3 is 3. 8 these are 24. Moreover, plus minus minus 24. Have we got this 24? 2 root 3 we multiplied with 4 root 3. First multiply the number. 2 fours are 8. 3 root 3, 3. Multiply them. 8 threes are 20. Here, now root 7 square is 49. How to make square of this? If you are unable, just you write it down. It will make you clear. 4 fours are 16. Root 3 is 3. 16 threes are 48. Minus 48. Now subtract them. 35 and 24 can be subtracted because they are like term. 34 minus 24 is 11. Minus plus again minus. Simple math only. Plus minus, big number sign is negative. So minus 20 minus 14 is 6 root 3. As they are like terms, whatever the root part is there, that we will keep as it is. Now 49 minus 48 is 1. You need to write it. This is your final answer. Is it clear? This time I want some response. Understood, everyone? Please respond. How many of you understood? Only one response is there. Most understood then. Rest of all, Ritvik was there. Shivalli was there. I don't know whether she's there or not. Ananya was there. Is it clear? Okay, let's wind up now. It's already around 50 minutes. Or should I take 5 minutes more? What do you want? Okay, tomorrow the textbook will continue. One more question like that. Very interesting one. Only one more I'll explain. Then you will enjoy like how we did this question. So this is a little bigger question. I need complete page. Okay. This time, like I'll be writing in this way. Okay, 5 minutes more. Very interesting question. This is like logic based. How we are going to solve. So let's move out with this. Question is 1 upon 1 plus root 2, 1 upon root 2 plus root 3, 1 upon root 3 plus root 4, 1 upon root 4 plus root 5, then it's not fully visible. No? I need to write it this way on this. Okay. Write the question once again. 1 upon 1 plus root 2, 1 upon root 2 plus root 3, 1 upon root 3 plus root 4, 1 upon root 4 plus root 5 upon root 5 plus root 6, 1 upon root 6 plus root 7, 1 upon root 7 plus root 8. Finally, it's got over. What is the answer for this? Can you think? Is this question interesting? Yeah, question is so big. Answer will be only very small, like the small answer only. How we are going to solve? First of all, always whenever you rationalize, keep in mind like you'll be taking bigger number first. Here, out of these two, bigger number is 2. Here, 3, 4. Try to arrange in that way. Next step, whatever sign is there, we need to take opposite, as I told. So here, we are multiplying opposite of that and changing the arrangement. First, taking the big number. So here, root 2 plus 1 in numerator. Here, 1 plus root 2 is there. If we take it root 2 plus 1, we need to multiply its opposite sign here. The first step will be multiplying the denominator's opposite sign. 1 plus root 2 is there. We need to multiply 1 minus root 2. And as I made the arrangement different, it will be root 2 minus root 1. So the first step is root 2 minus root 1. If you make the square, root 2 square is 2. 2 minus 1 is 1. No need to write anything in denominator. Again, for this, to change arrangement, first root 3 will come minus root 2. Again, 3 minus 2 is 1. No need to write anything. Now here, again we'll change. So it's root 4 minus root 3. 4 minus 3 is 1. Here, root 5 minus root 4 plus root 5 minus root 4. Here it will be root 6 minus root 5. Next, root 7 minus root 6. Next one, root 8 minus root 7. Next, root 9 minus root 8. All these are in addition form. You know the arithmetic. You can cancel out the opposite signs. So what we are going to cancel out here? Minus root 8 plus root 8, minus root 7 plus root 7, root 6, root 6, root 5, root 5, minus root 4 plus root 4, minus root 3 plus root 3, minus root 2 plus root 2. We left out with two numbers. One is minus 1, other is root 9. Root 9 is nothing but 3. 3 3s are 9. So root 9 we can change as 3. 3 minus 1 is 2. The final answer. Felt it to be interesting and easy? Okay, you wrote it 1. Answer is 2. Perfect. Answer is 2. Understood? Somewhat around. No, 0 is not the answer. Just now we got 2. See here. Root 9 square is 3. 3 minus 1 is 2. Here. Perfect. Is it clear? Okay, whoever attended, it's too late now. Thank you for attending. And moreover, if you understood, feel it to be happy to make concept to be interesting and easy for you. As I was not having book, so today I was unable to share it with the exercise. If tomorrow possible and if you all will agree, tomorrow onwards we'll start out with the textbook sums. Okay, now I'm winding class. Without wasting much more time, all of you go to bed. Don't play with your mobile. Okay, good night to everyone. Thanks for watching.